back. FMEA helps us in managing risks by classifying the process inputs and monitoring their effects. This is extremely important during a project. We do prioritization of X's using XY diagram. FMEA further helps in analyzing critical X's and in identifying the potential ways in which a process may fail to meet customer requirements. In this lesson, we will learn how to use FMEA to evaluate a process or product and determine what might cause it to fail. We will also understand about using scale criteria, calculating the risk priority number, and analyze the results. FMEA is a quantitative analysis tool for assessing risk associated with the different ways in which the component, product, input, or process could fail to perform its intended function. Failure modes may be the result of upstream operations or may cause downstream operations to fail. FMEA helps in identifying the effect of those failures and provides a structure for revising the design or process to mitigate the risk where necessary. It is a kind of inductive process and involves questions like if this failure occurs then what? It is a method for quantitative risk analysis and is useful in comparing designs. FMEA also helps in process improvement as it identifies and eliminates concerns early in the development of a process or design. Since it focuses on prevention, eventually we also get an improved internal and external customer satisfaction. In essence, it points to process failures that are most difficult to detect. During a Six Sigma project, inputs to a design or process FMEA can be considered from the XY matrix, process map, process history and experiences. The outputs of FMEA are usually a list of corrective and preventive measures and action items along with responsibilities and closure date, etc. Here are the types of FMEA commonly practiced. System FMEA is done to identify potential failure modes associated with the modules of a system caused by the design. Equipment FMEA is used to analyze failure modes of any equipment used in the process. Design FMEA is done in design phase to assess the potential failures in the product before it goes into production. Process FMEA is done to analyze the process and its potential failure modes which may seep through and reach to the customer. FMEA should be done early in the process improvement investigation. Like, while we are clear about the problem statement and have started studying the process, we should perform a process FMEA. Other instances when FMEA should be done are when there are new systems or products being designed, or when the existing systems or products are redesigned, or when a design is being implemented in newer systems. In general, FMEA can be done in the following steps. The high-value process inputs that are identified in the XY diagram are put down in the FMEA template, and the ways in which the input can go wrong are determined. Then against each failure mode, effects are determined and their severity level is entered, based on consensus that how much this will impact the outcome. Severity is usually rated on a scale of 5 or 10. Against each effect, potential causes are determined and their probability of occurrence is rated. Then we identify existing controls, if any, which can detect the failure mode and on that basis rate the detection level. These three ratings when multiplied give us a value that is known as risk priority number. Risk priority number helps in prioritization. The failure modes with high RPN are chosen and their mitigation plan is made. Based on the identified actions, RPN is again assessed and compared. The FMEA is not one-time exercise, we have to revise and review it regularly. Now let us see an example of FMEA. Here in this hypothetical example from Alex's case, the paint of chair frame is the function where we are applying FMEA. We identify potential failure modes, as insufficient paint coverage. Now we rate the severity of this failure mode. Then we identify what are the potential causes leading to these failures. Each cause is then rated with probability of occurrence. Then we write down the current measures which can help in controlling the identified causes, and their chance of detection is rated. Finally, we calculate the risk priority number and provide action plans which can help in preventing the failure mode or increase the detection of causes. Action item log is maintained for each of the high RPN failure modes. Once actions are taken, the state is again evaluated and rating is done again to see if RPN has reduced or not. This template can be found in the toolkit on the resource page. In this module, we covered the various aspects of process definition. We saw how process mapping is done, what is the value stream mapping, SIPOC analysis. We also learnt about cause and effect analysis, and how it helps in finding the factors which are impacting the process outcome. And then use of the XY matrix, which further helps in prioritizing excess or the input factors. And a few minutes ago we covered failure mode effect analysis, and learnt how it helps in analyzing critical X's and in identifying the potential ways in which process may fail to meet customer requirements. Now we will move to the next lesson. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.